Start. Let's find the volume of the solid obtained by rotating the region enclosed by y equals x and y equals x squared about the line y equals 2. So I'm pretty sure we talked about this region before, enclosed by y equals x squared. We graphed it before. Let me draw the graph again. So we have it. They intersect at 0, 0 and 1, 1. One of them is a line. And the other one is a parabola. It's going to be underneath here. So we saw this picture last time, and the only difference now, I'm rotating about the line y equals 2. So let me graph y equals 2. And that's going to be this line right here. I'm going to draw it as a dotted line. Okay. And this, well, maybe I'll do a solid line. That's fine. And I want to rotate about this line. Okay. So remember that we want to take our strips perpendicular to our rotation line. So here's my line. Perpendicular would be up and down. So my strips I'm going to take are going to be up and down. And we rotate it around our line. Notice my strips don't touch my rotation line, right? So what I'm getting is that washer that I got last time. There's a big hole in the middle of this. Okay. All right. So my cross-sectional area, A of x, it's pi big R squared minus pi little r squared. Where big R represents my outer radius, my biggest radius that I've got, and little r represents my smaller radius. So let's start with little r. Okay. Which one of these curves here is closest to my rotation line? The line or the parabola? Which one is closest to my rotation line? The line. Okay, so that's the one that's going to give me the little r that I want. Okay. And the little r, it's going to be this distance right here, little r. Now it's a lot more difficult to find little r this time than it was previously. I know that this total distance from top to bottom here is 2. And then this little distance here is a y, which is equal to x. So if I want the blue distance, to get blue, I've got to take the bigger red and subtract the smaller red. So it looks like my little r is going to be 2 minus x. Okay. So again, my goal was to get this blue distance, this little r. I take the whole distance 2 and subtract this distance, which is x. So let's see if we can find big R now. Big R. What do you think? Big R. Oh, I need another color. Big R is the distance down to the parabola. That's big R. So I'm going to take 2 minus my little distance here underneath comes from the parabola, which was x squared. 2 minus x squared. Are we all okay with how I found those radius? This is the hard part in setting this whole thing up. Finding your little r and your big R. Are we all okay or no? Do I need to explain anymore? The big R. So I wanted this green part here. This is my big R. So I do the same thing I did over there. I go a distance of 2, but then I've got to subtract off this extra distance here at the bottom. So I subtract off this extra distance, comes from the equation y equals x squared. So I subtract x squared. It's coming from the fact that I'm counting this distance here. So let me try. So let me do another, well, I guess red here. This distance right here is y equals x squared. So to get the big R, the green, what I do is take my red 2 distance, the all distance all the way down, 2, and then I subtract off this little red distance here. So I take 2, and I subtract off this, and that'll give me the green. Are you okay now? All right. I know it's a lot. So once we know little r and big R, we just plug it into our formula here. So the volume, I'm going to integrate in terms of x. The volume is the integral pi big R squared 2 minus x squared minus pi little r squared. And then what was my range? What are my values on x that I could have between, what's the smallest x could be? 0, the largest? 1. So my bounds are 0 to 1. Okay. Pull out the pi out of both terms. So you get pi. And then let's square the first 2 minus x squared squared. So that's 4 minus 4x squared plus x to the 4th minus, and then square 2 minus x squared, 4 minus 4x plus x squared. So I did 2 things at once. I pulled out the pi, and then I squared all those terms, foiled. And if you do that, you'll be left with pi, gonna roll from 0 to 1, 4x minus 5x squared plus x to the 4th. dx. And this is just a polynomial. Integrating it is not difficult. Right, we just do our reverse power rule where we add 1 to the power. So you should be getting pi 2x squared minus 5x cubed over 3 plus x to the 5th over 5 from 0 to 1. When I plug in 0, those are all 0. So it looks like pi 2 minus 5/3 plus 1/5. And if you get a common denominator, you would get 8 pi over 15. Okay. Again, from my perspective, I think that the majority of the hard work comes in, one, you get a picture of your region, and really, two, when you're not rotating on an axis line, it's really not so easy to find these two values, r and little r, big R and little r. They depend on your picture and your setup, okay?